Hi friends, welcome to the 8th part of NEET Series 2020. Let's discuss let's continue our discussion on the graphical interpretation of problems. Now the 6th problem. Adsorption of a gas follows of Rutledge adsorption isotherm. In the given plot, X is the mass of the gas adsorbed on mass M of the adsorbent at pressure P. So X by M is proportional to, we need to find out which among the following four options is right. Now a graph has been given in which in y-axis there are 2 units and x-axis there are 4 units for this slope. Okay, I know that a Rutledge isotherm is like x by m is equal to k into p power 1 by n. Okay, taking log of x by m is equal to log k plus 1 by n into log p. I can write like this, and it looks like this part looks like y, and this part looks like c, and this part looks like m, and this part looks like x. However, from the graph I can write like y by x. This is y, okay, this is y, which means it is 2, and this is x, and I can write like 4, so 1 by 2. Okay, but I know that this is a constant, which means 1 by n is equal to 1 by 2, therefore n is equal to 2. So putting this equation, I mean the values of n by 2, n is equal to 2 in the equation, I'll get p power 1 by 2. Okay, here p power 1 by 2, which means option A is the right answer. 7th one. An endothermic reaction with a high activation energy for the forward reaction can be shown by the figure. So there are 4 figures given: A, B, of course this is A, this is B, this is C, and this is D. Fine. So if there is a large gap between the potential energy of a reactant and that of the product, that represents high activation energy. So this third graph satisfies that, because it has a very high activation energy, and this is the energy difference between the reactants and products, which means option C is the right answer. So 8th problem. The correct statement is, here an Ellingen diagram is given, and okay, we need to find out which is the correct statement. Okay, let us read one after another. Statement A goes like this: at 500 degrees Celsius, coke can be used for the extraction of zinc from zinc oxide. So coke is here, and this is coke, and zinc curve is here. Okay, this is zinc curve, which means at 800 degrees Celsius, no, at 500 degrees Celsius, my coke curve is above zinc curve, which means it cannot reduce. So option A is wrong. Second one, at 1400 degrees Celsius, aluminium can be used for the extraction of zinc. 1400. Okay, my aluminium curve is always below the zinc curve, which means it can reduce, aluminium can reduce zinc, which means B is the right answer. Let me check the other 2 options also. At 800 degrees Celsius, copper can be used for the extraction of zinc. Copper curve is here, but copper is always above zinc curve, which means it cannot reduce. So option C is wrong. Coke cannot be used for the extraction of copper copper from copper 1 oxide, but copper is almost below. Coke curve is almost below copper, which means a coke can reduce copper, which means this is also wrong answer. So option B is the right answer. Which of the graphs shown below doesn't represent a relationship between incident light and the electron ejected from the metal surface? I know that h nu is equal to h nu naught, which is nothing but work function plus kinetic energy of electrons, right? So the kinetic energy of electrons is directly proportional to the intensity of light. Intensity of light. So which means they will vary directly. So option, this graph is right. Third graph is the right answer. Question number 10. For a diatomic ideal gas in a closed system, which of the following plot doesn't correctly describe the relation between various thermodynamic qualities? Okay, which doesn't correctly describe. And in the first graph, Cv is constant with volume, because Cv is nothing but heat capacity at constant volume, which means this graph is right. Option B, internal energy varies directly with temperature. Yes, this is also correct. So, heat capacity at constant pressure varies directly with pressure, which is wrong. Okay, Cp will be constant with pressure. So the graph should be like this, should not be like this. So this is the right answer. Okay. Thank you guys. Happy learning.